Hello there, welcome back to STR8CHEM. In this video, we're going to learn about the Chatelier principle, and this principle states that if a stress is applied to a reaction that is already at equilibrium, the reaction will counteract the way to reduce the effects of the stress or to relieve the stress to gain a new state of equilibrium. There are three types of stress that you need to know for the Chatelier principle. The first one we're going to look at is on concentration, which is the easiest one. And then we're going to look at the effects of temperature. And then the third one, we're going to look at pressure. And usually when we talk about pressure, it will come together with volume. So these are the three stress that we look at on the discussion about the Chatelier principle. Now we're going to look at the third type of stress that we can apply it on a chemical equilibrium reaction, which is pressure and volume. Pressure and volume will come together because when you change the volume of the vessel, the pressure will change as well. So how do you relate this? How do you understand the relationship between pressure and volume? We can always go back to our PV equals to nRT equation over here. When we rearrange PV equals to nRT, you would get P equals to nRT over V. From this rearrangement, we can see that the relationship between pressure and volume over here is inversely proportional. That means if you increase the volume of the vessel, you increase the volume of the gas, you are going to decrease the pressure. From the relationship, we know that pressure is inversely proportional to volume. Okay, so means when pressure increase, volume will decrease. When pressure decrease, volume will increase. So when volume increases, pressure will decrease. When volume decreases, pressure will increase. So that is the relationship between pressure and volume. And that's the reason why we always need to relate between those two when we want to consider the stress of pressure. Or if it's easier for you to imagine that, you can look at this diagram over here. When you have larger volume, you will have lower pressure because you have fewer collisions per unit volume inside this vessel. Okay, means the molecules, the particles of the gases will have more interparticle space between them, and they can move even further away from one another, making the collisions to be even fewer. But when you make the volume to be smaller, okay, when you make the volume to be smaller, you will have higher pressure because now you will get more collisions per unit volume inside this vessel. Okay. If we're going to look at this one, this is one very important thing that you need to know for pressure and volume. Unlike temperature and concentration, especially for concentration, which is quite straightforward, for pressure and volume, we have to consider the number of mole of the gaseous species. There will be a situation in which no matter how much you're going to change the pressure or the volume of the vessel, the equilibrium will not going to shift because of the situation now will depend on the number of mole of the gaseous species. To understand the effects of pressure and volume on a equilibrium, we have to think the reaction over here as a whole system. So we cannot change the pressure of the species individually because all of them will be placed in the same vessel, okay? So all of them will be placed in the same vessel. All of this gases that we have over here, your H2, your N2 will be in there as well, and also NH3 will be inside the same vessel. So when we change the pressure and volume, this whole thing over here, the whole system will be affected in the same time. Okay, so that's why we're going to look at the number of mole of gaseous species. It's not like concentration. For concentration, we can simply change this, and we can change maybe this one, or maybe you want to change this, or you want to change both of them at the same time. We can do that for concentration. But for pressure and volume, we have to think this whole thing over here as a single system that is placed inside a vessel. So when you change the pressure, you are changing it for all of them at the same time. When you change the volume, you are changing the volume for all of them at the same time. So that is the first thing you need to set in your mind, okay? So next we're going to look at how we're going to apply the idea of number of mole of the gaseous species in determining the direction of the equilibrium shifting. So the first thing, if you get this kind of questions in exams, when they ask you what happens with the equilibrium shifting if we're going to increase the pressure or decrease the pressure, the first thing you need to do is you need to look at your products, your reactant over here. So for your reactant, you need to look at how many mole of gaseous species we have. We have 3 plus 1. So we have 4 mole for your reactant side. And then when we look at your product side, we have 2 mole. So we have 2 mole. So clearly, the equilibrium system, it has 2 different value of gaseous mole for the reactants and the products. So what happens if we increase the pressure? So if we increase pressure of the system, what happened? So when we increase the pressure, the system will try to counteract to that stress by shifting to make the fewer number of mole of gas, okay, to reduce the effects of increasing of pressure. So when you increase the pressure, the equilibrium shifts to the fewer number of gaseous mole. So you're gonna be making, therefore, making more of NH3 gas. The reason is because you want to reduce Okay, so if we're going to increase the pressure of the system, the equilibrium will shift to the fewer number of gases mole. So it will shift to here, to your, in this case, you're going to shift to your right. So you're going to make more of this. You're going to make less this, because if you have more of this, you will make the pressure to be even higher. And that one is not going to be at equilibrium. You increase the pressure, so the reaction will counteract and they will make fewer of this. They will move to the fewer number of mole. So you have more of this inside the vessel. Then you will counteract the effects of pressure being increased. If we're going to be reducing the pressure, what happens if we're going to be reducing the pressure of the system? So when you reduce pressure, you're also going to be increasing volume. Okay, so when you increase the volume, you are reducing the pressure. So what happens if you reduce pressure or increase the volume? You have to look at the number of mole of your gaseous species. Over here you have 4 mole, you have 2 mole. Now you are reducing pressure. So you want to increase the equilibrium, want to increase the pressure now because you reduce the pressure. So how do you do that? How do the reaction do that? So you will shift to the more number of mole of gas. So the equilibrium shifts to the side with more number of gaseous mole. This is to with the reduce pressure. So that means the reaction exerts more pressure. Okay? So let's have a look at another example. If we look at this example here, first of all, we have to look at the reactant, and you have to look at the product of how many mole of the gaseous species. Over here you have 2 mole. Over here you have 1 and 2 mole of gaseous species as well. Okay, 1 plus 1 is 2, so you have 2 mole. In this case, when you have 2 mole of gas on the reactant side and 2 mole of gas on the product side, they have the same number of mole of gaseous species. What will happen? Changing the pressure and volume does not change the equilibrium. Therefore, what can we say? No shift. Okay, so in this case, you will not gonna see any shifting. Okay, you don't have any movement of equilibrium position to the fewer or to the more or to the left or right. because you have the same number of mole of gaseous species, no matter how much you're going to change the pressure or the volume. Another example here. So this one is considering a heterogeneous reaction. Okay, so you have to look at this reaction, reversible reactions over here. As you can see, that one is a solid. Meanwhile, all of them over here are gas. Therefore, this one is a heterogeneous reaction. So we're going to look at number of mole of gaseous species on the product side is going to be 2 mole. Number of mole of gaseous species over here will be 1 mole. Okay, because this solid, pure solid, and liquid is ignored. Okay, so now what happened then? So you have a different number of mole of gaseous species on both sides. So when you change the pressure and volume, you will get a equilibrium shifting. So when you increase the pressure, so in this case right now, when you increase the pressure or when you reduce the volume, what happened? The equilibrium shifts to the fewer number of mole of gaseous species. Okay, so it's the same as what we have talked about at the beginning. But the only thing I want to emphasize on this bit is for you to be careful when you look at the phases right now. You have to consider whether it's going to be solid, liquid, gas, or aqueous. So only gas and aqueous will be considered in your equilibrium. But to be more specific, in the case of pressure and volume, we're only going to consider gas, okay? Aqueous also will not going to be involved in this effects of pressure and volume. So you have to remember that. Another part of effect of pressure and volume that we need to look at for system at equilibrium is when we're going to add inert gas into the gaseous system at equilibrium. So before we're going to look at 2 examples, we have to know first what does it mean by inert gas. So inert gas, the examples are such as we can have neon, we can have gas like helium, and we have gas like xenon and argon gas. Okay, so these are the gases from group 18. So these gas, when you add them into the gaseous system at equilibrium, since they are inert, they will not gonna, this gases over here won't chemically change the reaction. That means the inert gas, when you add them into the gaseous system, they will not gonna react with the species in the system. So to visualize that, I have a situation over here of which we have 2 mole of NO gas reacting with 1 mole of oxygen gas to make 2 mole of NO2 gas. it's obvious that we have 3 mole of reactants and 2 mole of products. So we have a difference in the number of mole of gaseous species. Therefore, when you change the pressure and when you change the volume of the vessel over here, you will have shifting in the equilibrium. So to imagine the situation when we want to add inert gas into the system, we have to think of this equilibrium system exists in a closed vessel like what we have here. So at this point, when we have achieved the equilibrium, we have NO gas exists, okay? So that is representing the NO gas, the blue color. And we also have the oxygen gas inside the closed system. Since we have achieved equilibrium, we have produced a product right here. We're also going to have the NO2 gas exists at equilibrium. At this point, equilibrium has been achieved. Nothing will be changing unless you're going to change the volume of the vessel. So when you change the volume of the vessel, the pressure will change. Okay, remember we have talked about pressure and volume, they are related. So when volume decrease, pressure will increase. So when pressure, you want to decrease the pressure of what you have in here, the volume of your vessel, you will need to increase the volume of the vessel. So this is the relationship that we need to know about pressure and volume. It will still going to be applicable in this case, but it will be slightly different now when you have inert gas, because the inert gas, when we start to add inert gas, so let's say you have plugged into some sort of plug-in there, and then you have injected inert gas inside. So we're going to start to put inert gas. Maybe you're going to have argon, or maybe you're going to have some neon gas, or maybe you're going to have some helium gas. Okay? So in this case, when you start to add inert gas, you will start to have the inert gas to be in the system. But when the inert gas is in the system now, these gases will not going to affect all of this chemically. So you don't have NO to be reacting with the inert gas, or oxygen to be reacting with the inert gas, or even the NO2 to be reacting with the inert gas. That's why we call it inert gas, because they are stable, because they are from group 18. Therefore, they will not going to be reacting with all of these species over here when you add them into the system. But what will change now, the introduction of inert gas will for sure change the total pressure inside. Okay? Because we do know that we have partial pressure of NO. We have partial pressure of O2. And we have partial pressure of NO2. Before we add inert gas, the P total will be the summation of all of this partial pressure at equilibrium, all of this species over here. But when you start to put inert gas, the P total now would be affected by the partial pressure of the inert gas. Okay, so that is the only thing that will be changing over here, the total pressure in the closed system when you start to add inert gas. There are two situations we need to consider when you want to talk about the effects of adding inert gas into a system at equilibrium. The first one, we're going to look at the situation in which you're going to add inert gas at constant volume. At constant volume. What does it mean by constant volume over here? The word volume, okay, the word volume over here referring to the volume of the vessel. So we want to talk about the word volume. So we want to keep the volume of the vessel constant. Okay, so we want to keep the volume of the vessel constant. We're not going to change this. So as we keep on injecting inert gas, so you can imagine that we keep on putting more and more inert gas into this closed system, what will happen to the total pressure? The total pressure will increase. Remember, the total pressure will increase because you keep on adding inert gas inside here. So for sure, right now, the total pressure, as you keep on adding inert gas inside, because you keep the volume of the vessel constant, the P total will increase. Okay? But what happens to the equilibrium then? Does the equilibrium shift or does it not shift? So to know that, we have to keep in mind that the P total will increase. Okay? P total will surely increase. The P total will surely going to be increasing. Why? Because you keep on adding inert gas. So a lot more. So the inert gas will be becoming more and more inside, making the P total to be increasing. Again, I repeat, because the P total now, when you add inert gas, is the partial pressure of all of the reacting gases over here together with the partial pressure of the inert gas. So as the partial pressure of inert gas increase, even though these are not going to be changing, your P total will increase. So this is what the statement is trying to convey over here. P total increase because you want to keep the volume of the vessel constant. But what you have here is this. The partial pressure of we need to change that. The partial pressure of the NO, O2, and NO2. Okay, so the partial pressure of all of the reacting gases in here will be unchanged. Okay, the partial pressure of NO, O2, and NO2 is unchanged. Why? Because we're not adding any more of the reacting gases, and the volume of this vessel is constant. So pressure is not going to be, the partial pressure is not going to be changing. But the reason why P total increased because you keep on injecting gas. You keep on adding inert gas into this vessel, and you're not changing the volume of the vessel. Okay? Therefore, when the partial pressure of NO, O2, and NO2 is unchanged, there will be no shifts. Therefore, the reaction now, when you add inert gas at constant volume, it will always gonna stay at equilibrium. So no shifting will occur. It will be different though for this situation. Now we have a second situation when you're gonna add inert gas at constant pressure. So now you want to keep the P total to be constant. So let's say before adding inert, the P total is 8. Okay, so before you add inert gas, the P total in here is, let's say, gonna be 8 atm. Okay, so what we want to do now, you want to add inert gas. So you're going to start to inject inert gas into your vessel. And in this situation now, you want to keep the total pressure to be constant at 8 atm. If you don't change the volume, of your vessel and you keep on adding inert gas, your P total will increase. So how do you make the P total to be constant when you keep on adding inert gas inside? You have to increase the volume of the vessel. So when you increase the volume of the vessel, automatically the partial pressure of your NO, O2, and NO2 will be affected. They will change because now the vessel that they are in is changing. Remember, ideal gas, the volume will depending on the volume of the vessel. So when the volume of the vessel changes, the partial pressure of all of this will change. Therefore, equilibrium will change as well, depending on the number of mole of gas for sure. And when you look at your equation over here, you have 2 mole of NO, 1 mole of O2. So you have 3 mole of gas, 2 mole over here. Therefore, when you increase the volume, the pressure will decrease. You will have a shifting. Okay? So that is the reason why when you want to keep at constant P total at 8 atm in this case, you're going to increase the volume of the vessel. Okay, so let's have a look at how you're going to write your answer in exam. So to keep the total pressure constant, volume of vessel must increase. Okay, so you must increase the volume of the vessel over here because you want to keep the P total constant as you add inert gas inside, as you inject inert gas inside. You want to keep the total pressure to be 8 all the time. So you have to increase the volume of the vessel. So when you change the volume of the vessel, what will happen? When you change the volume of the vessel, you will change the partial pressure of these gases. You're going to change the pressure of NO, O2, and NO2. So when you change the volume of the vessel, automatically the partial pressure of NO, O2, and NO2 will change. So when you change the partial pressure of your reacting gases, so what will happen? When the volume increase, pressure will decrease. Okay, pressure will decrease. It will shift to the more number of mole of gas, forming more of the NO and O2. You're going to be forming more of this because you want to shift to the more number of mole of gas. So remember, we have talked about this in the beginning of the video. That one will be 3 mole. This one is 2 mole. So when the pressure decrease, because you have to increase the volume now, when you add inert gas, it will shift to the more number of mole of gas. Therefore, you're going to form more NO and O2 in order for you to achieve the new sets of equilibrium.